Okay, here we go. All right, so I like this video. It's kind of cool how they show the atoms here.
It is only in the last 100 or so years that humankind has understood that the nucleus of the chemical elements is not always fixed. It can change spontaneously from one element to another. The name for this process is radioactivity. You probably already know something about the nucleus. It's much tinier than the atom. It's made of particles called protons and neutrons. There are electrons orbiting around it. And though the atoms can share or swap electrons when they bond together, the nuclei themselves never change. Right? Well, no. Certain nuclei are not stable in that way.
So when those two hydrogens are throwing their electrons back and forth, the point is they're staying hydrogen. So in this picture here, they're throwing it, but this is hydrogen, that's hydrogen. So when two hydrogen atoms bond and they form a chemical bond between them, kind of like this marker here, there's a chemical bond. This hydrogen stays hydrogen, and this hydrogen stays hydrogen. That's because they use electrons to bond. That's outside the nucleus. That's like normal chemistry, and that's how everything works, except nuclear. Nuclear is its own little branch, and it's really bizarre because the elements start turning into different elements randomly. What's spontaneous mean?
Random.
Random, okay.
Predictable.
Unpredictable, what'd you say? Sudden.
So,
What if I just threw this statement out? True or false, humans must interact with elements to make them spontaneously change? True or false, humans must interact with atoms to make them spontaneously change?
True. I'm saying false. I'm saying false.
Yeah, it's false. If they spontaneously change, then we don't need to get involved. Okay? Where do we use that word in real life?
Spontaneous?
Yeah.
Like when someone does something in the spur of the moment.
Spur of the moment. Someone just decide, you know, what if Shane just jumped up, screamed at the top of his lungs, and then jumped out the rest of the Alright?
That would be great.
Like a war cry. And then he didn't even open the window, he just blasted right through the window.
That would be
Bird
great.
box. Took off his blindfold.
So, that would be spontaneous and completely random, right? So that's kind of where we use the term. What about spontaneous combustion?
It just lights and fire explodes.
Seems to just explode or light on fire on its own,
This
right?
is the second time today I heard this word. We talked about it in small animal care.
What?
We're talking about spontaneous mutation.
Was there anybody, okay, not combustion.
No.
Okay, so what would they, what'd you
She
learn?
just said it's a random change or something.
Okay, are you talking about genes?
Yeah.
Like in your body?
No, in like dogs and animals.
Okay, alright, but in their genes, in their DNA, right?
Yeah.
Yeah. Yeah, that's how some diseases are passed genetically. It's like a genetically mutated gene, but if you trace it back, it just kind of mutated on its own, like spontaneously. And that can happen, yeah. But anyways, what's spontaneous combustion? Where something seems to just burst into flames. Now, is this paper going to burst into flames ever? No.
No.
It can't just spontaneously combust. Well, what can?
Propane.
Things that are flammable, but okay, how's
They have to
propane?
react, like they have to get lit or something.
Well, right. So it looks like it's almost spontaneous
Gas.
and nothing happened, but it
Gasoline.
happens on a molecular level kind of slowly, and then all of a sudden it reaches a point where it gets hot enough or the flash point is reached, and then it bursts into flames. I'll give you an example. Those red rags that mechanics use, anyone familiar with those?
Yeah.
Okay, you're supposed, after you use them, especially wiping your hands or whatever tools with grease on it, you're supposed to put them in this metal container because they can
Like a
spontaneously, yeah, kind of, but it has a
Okay.
cover on it. So if something happens, it's contained. So that's because of the oil and the grease that are soaked into the fabric. You ever stain anything with a rag, like wood, deck, or I don't know, piece of furniture? You're not supposed to put those rags in direct sunlight. They could spontaneously combust. But they don't just combust for no reason. Take the sunlight. The sunlight does what to it? It heats it up, gets the particles moving faster, and eventually they get to the point where they're warm enough to ignite. So it isn't like, you know, humans can't spontaneously combust, right? So this morning, a couple students were trying to tell me that they can. There's a video online. She burned from the inside out, and I said, "Oh, that's great. That can't happen. So that's not true."
Photoshop.
So whatever that video was, it's nonsense. But anyways,
Sounds fake.
so that's the word spontaneous. Let's stay with me. The word spontaneous, and you're going to see it in a second, is when, and how we're using it here, is when one element turns into another element on its own without any human involvement. That's how I want you to understand it. So I have radioactive discs in the back. I'm going to show you tomorrow. I'm going to take them out, put them on the table. I'll hold the Geiger sensor to it. It beeps. It starts beeping because the radiation coming off of it registers with the sensor. So the disc naturally, spontaneously emits radiation. I don't have to turn it on. I don't have to do anything to it. It just kind of works. So that's kind of, not a great technical definition, but that's how I want you to think of it. So these elements spontaneously give off radiation on their own. Humans don't have to do anything to it. All right, it's just natural. It happens naturally. Okay. So that's why those different words, natural transmutation, natural decay, also spontaneous is another word. Okay. So moving on.
Right? Well, no. Certain nuclei are not stable in that way. This means they may change suddenly, spontaneously. The radioactive nucleus flings out a small particle and transforms into another element, just like that. For example, the carbon nucleus can eject a fast-moving electron.
Yeah, so carbon sneezes. All right, now that would be terrifying if every time you sneeze you turn into someone else. So you sneeze and you turn into Tyler and start saying howdy. So carbon ejects, what's this?
Electron.
Beta particle.
Beta.
Beta.
It's beta, and then it turns into nitrogen. That's exactly the one I just had right here. One in our notes. It's exactly what happens.
Wait, why is it called?
It's the same thing. A beta particle has the same structure and charge as an electron. It's 0/-1e. They're the same particle.
Okay.
It's just, here's
What's more
the
exciting?
crazy
It came
part.
from the nucleus.
Right, when it comes from the nucleus, we call it beta. When it's just an electron, it's just an electron.
Where did
But
that come from?
where
Right.
do they come?
They're going to talk about it. And I'll admit, ultimately, I don't know either. I don't know what causes it to change and how that gets created. I have an idea, it's the quarks, but I don't fully get it myself. I'll be honest.
Electrons enter into a nitrogen nucleus. There are two different particles that can be emitted from radioactive nuclei, though never together. The very fast electron is known as a beta particle. If you know a little bit about electrons, you may be thinking, what was the electron doing in the nucleus in the first place? The answer is that a neutron in the nucleus spontaneously changed into a proton, which stayed behind.
Wait, what?
And the electron flew out as a beta particle.
Wait,
So
what?
when a
How is it
neutron
like
turns
naturally-
into a proton, right? So here's a neutron, here's a proton. When this turns into a proton, it ejects an electron.
How does it?
Why does that make
naturally
sense?
turn into a proton?
Because
that's composites.
But if it's going from a neutral charge to a positive charge, it's got to get rid of a negative.
So do protons and neutrons contain electrons?
So protons, neutrons are made up of quarks, and depending on their combination, that says, okay, you're a neutron, you're a proton, and then an electron is a part of that as well. It's a different combination. So the quarks are changing, and that changes a neutron to proton. That part I get, and I can understand that. We don't need to really get into quarks and spend time on that. It's not on the regents. It's interesting though. But then why that happens, I'm confused over. And I know it does it to try and become more stable, but maybe how is a better word. How it does that, how the quarks just decide to change, that's the part that's confusing.
Say there's more protons than neutrons. Can a proton turn into a neutron? Like reverse?
Yeah, if the quarks change, it's like 2 ups and a down is a proton, and 2 downs and an up is a neutron. I forget which it is, but yeah.
Okay.
Yeah, so, yes. So, that's what's crazy about nuclear chemistry, is this stuff just happens spontaneously on its own. Alright, so anyways, that's where the beta comes from. You know what? Just because I think it'll help the conversation, I'll look more into the quarks and get the exact explanation of those, and I'll talk a little bit more tomorrow about that. Yeah.
Okay, so in a block of uranium,
Mhm.
there's millions and millions and millions of atoms.
Yeah, trillions and trillions.
A lot.
Yeah.
Would like one atom's like radiation, like one beta particle, would that make a significant effect on anything?
No. It's the culmination or combination is a better word. of all. Yeah. Yeah, so like the radioactive stuff I have, it's extremely weak. They're not gonna sell it to schools and teachers and have kids if it's like super concentrated and lots of radiation. You know, I keep it locked up and wrapped in lead anyway, but you know, yes, no, one atom isn't gonna be a big deal. Plus, that's alpha radiation, which is the least harmful. Hopefully, or that's what this means, penetrating power. I was going to get to here in a minute.
This is not what chemistry has taught us to expect. The nucleus is supposed to be stable. Neutrons don't change into protons, except sometimes they do. The other particle that emits spontaneously from an unstable nucleus is alpha. An alpha particle is 8,000 times more massive than beta, and it's a bit slower. Alpha is made from 2 protons and 2 neutrons. If we trap a lot of alpha particles together, we get helium gas. Alpha is a helium nucleus. Like the beta particle, we would not have expected a heavier nucleus to throw out helium. But again, it happens, and the nucleus becomes a new element. So, is radioactivity useful or just dangerous? Wherever you are sitting, it is quite likely that there is a device nearby which contains a source of alpha particles, a smoke detector. The source is radioactive americium. You are totally safe from these alpha particles, which cannot travel more than a few centimeters in air. Beta particles penetrate much further through materials than
Okay, so, well, here, hold on.
alpha can. Radioactive atoms are used in...
Okay, so the beta particle can go through a piece of paper, but the alpha cannot. So, penetrating power, I want you to write this down here. We'll go right to the bell. Here's your 4 types of radiation. You got your really big alpha, you got your really small beta and positron, and who remembers, what's gamma look like?
Waves.
It's a wave, right? Like. All right, and we'll end with this conversation here, and then we'll pick up with this tomorrow. But just don't forget the homework, those 5 radioactive decay equations. I sent it to remind, so you should be good to go. But alpha's really big, and that's what all your smoke detectors, my smoke detector, everyone's smoke detectors, that's what's going on. It has americium, and it's emitting alpha particles. And I'll explain tomorrow how that works, because I don't have time right now. But penetrating power, what that means is if I had 4 different radioactive guns in my hand, and I was shooting these radiation particles at you, one of them's really bad.
Beta.
Gamma.
Alpha.
Gamma's the worst.
That's right.
Hold it. Don't back up. Well, if you want to back up, fine, but I want you to write this down. Gamma has the highest penetrating, meaning if I was shooting Shane with a gamma gun, gamma would go right through his body. Like what? What goes
X-ray.
through by X-rays, sort of. What else?
Everything that's not visible.
Very small. So cosmic rays, gamma rays, X-rays.
X-rays.
Now UV rays are bad. I'll have to pick up tomorrow. I'll pick up with that tomorrow. Don't forget the homework in your notes.
The bottom of the screen looks confused. 72